He kōna e purangi tēnei nā te reo irirangi o Aotearoa.
I think it almost looks like a night sky with a little bit of white dots, different sizes.
Yeah, it's a starry night sky.
Yeah, it is.
Kia ora, nau mai haramai ki te ao hurahanga. Hello and welcome to Our Changing World. Ko Clec and Canon tēnei. Humanity has had a long and vexed relationship with the element lead. It's easy to work with, so long ago, think Roman Empire, it became the go-to metal for water pipes. It was useful in paint and excellent in petrol for stopping engine knock. But time and time again, we've been reminded how bad it is for human health, and efforts were made to replace it with less harmful substitutes. But there is one use for lead that has remained constant: bullets. However, as Alison Ballance finds out, there's concerning new research that might make us reconsider this too.
Eric Bouwens is a biomedical researcher at NMIT, the Nelson-Marlborough Institute of Technology. For the past decade, Eric and his colleague Gareth Parry have been interested in lead and its impact on human and animal health. Specifically, they have been investigating lead in ammunition. This is of special interest to Eric, who is a recreational hunter. He started off bow hunting in the United States before changing to guns.
So I started hunting with a muzzleloader. And the strange thing about a muzzleloader is that you actually take a bit of lead and you jam it down the end of it before you shoot. And I had shot a big elk, and I was cutting up the elk, and I found the bullet, and there was, not the whole bullet. There were the bullet and then little bits of bullet. And I thought, no, this might not be right. I'm not certain that I actually want to be eating this. And so, as a biomedical scientist, this got me thinking and started us on this research project. I converted to non-lead ammunition a long time ago.
These days, Eric, like most New Zealand hunters, shoots with a centrefire rifle, and he shows me 3 types of bullets that you can use.
So we have 3 bullets here. And this first one is a solid lead bullet, and it looks like a solid chunk of lead. The second one here is what most people will use. These are copper jacketed with a lead core. Copper jacketing is great to have in a bullet because it helps the barrel not foul as much. Then we'll go to the next one, which is a solid copper bullet. The most common ones are these copper jacketed bullets with the lead core.
Lead is a very useful metal. It's soft, versatile and cheap. It's also very toxic. The World Health Organization says that lead affects multiple body systems, that it accumulates, and it is particularly harmful to young children and women of childbearing age. There is no level of exposure to lead that is known to be without harmful effects. A few years ago, Eric had an encounter in the New Zealand bush that would prove pivotal to his research.
We were hunting in the bush, and I ended up meeting an individual who was hunting as well, and he happened to be eating a lot of meat that he was shooting himself. And we just had a chat about the kind of bullets he was using, as hunters do, and the rifles. And I asked him, I said, have you ever gotten a lead test? And he looked at me, he said, no, but I've kind of thought about it because I do eat a lot of meat. And we offered for him to have a lead test, and he had one, and his lead levels were very high. They were 16 times the level of concern.
Was he exhibiting symptoms?
Yeah, so he really didn't know that he had symptoms until he got off of lead. He stopped using lead and stopped eating it. And then he got better. He put weight back on again. He was getting this odd kind of gout that you usually don't get, but you get it with lead poisoning. So he stopped using lead ammunition, stopped eating lead. He put on quite a bit of weight. I think it was probably somewhere between 10 and 15 kgs.
Just to restate that, the World Health Organization says a blood lead level of 5 or more micrograms per decilitre is concerning. This hunter had almost 75. It seemed highly likely that this was all coming from lead ammunition, but this was something that Eric and his colleagues wanted to confirm.
We were lucky enough to get some funding to do additional work, and that additional work was really to question what the risk to the average New Zealand hunter is. And so for that study, we requested samples of meat from hunters throughout New Zealand. And we had people send samples of their meat from their freezer into us here at the Nelson-Marlborough Institute of Technology.
They received 44 samples of minced wild game meat.
And then we took those samples, and the Halifax Vet Center downtown kindly allowed us to put the samples on their X-ray machine.
Have you got an image of what one of these X-rays looks like after an animal's been shot?
I have a couple good images for you here. Yeah.
So you just pull one up on your computer?
I just pulled one up. So
there's bits of white everywhere.
There are, yeah. So those are bits of metal. And so we got all these samples in, put them on the X-ray table, ran the X-ray, and the vet would say, oh, yeah, okay, this was done, and then check it and make sure everything, and then every once in a while there'd be a, whoa, that's got something in it. And this was one of those ones. Yeah, so it almost, I think it almost looks like a night sky with a little bit of white dots, different sizes.
Yeah, it's a starry night sky.
Yeah, it is.
And those are all bits of metal from where the bullet has basically disintegrated.
Well, then, so as a strict scientist, we can't say that it's from the bullet. We just know that there's metal in there, and we don't even actually know what kind of metal, right?
Okay.
So we look at that and we say, okay, what can we do in order to actually make certain that it's lead or that it's not lead? And so that's why we went to the Cawthorn Institute, and they did a procedure that allows you to measure the exact amount of the various constituencies and the metals that are inside that sample. And that's where we found out that there was lead in them.
The Cawthorn Institute used inductively coupled plasma mass spectrometry, which showed that almost half of the samples of the wild game mints sent in by hunters contained lead levels exceeding the daily intake benchmarks for children. This included samples in which no lead had been identified in the X-ray screening.
What was really surprising and potentially concerning about the results from Cawthorn is that the X-ray only picks up little bits of lead that are relatively large. And so there's a lot of really small pieces of lead that are spread throughout the sample that you would never see. So if you're eating it, you would never know it. But we know that it's there because the analysis that was done at Cawthorn.
So are these metal fragments just along the trajectory where the bullet went through, or do they disperse more widely than that?
So this picture, it's a broadside picture of a deer that's been shot with lead ammunition. There's the rib bones, and there's a hole here where the bullet went in, but then there's all these fragments, and they actually travel all the way up into the neck, and they travel all the way down. You can catch them down here even, this is the liver, all the way back here.
They really spread out, don't they?
Yeah, so it's quite a range that they go. And that's why when you ask how far do they go, well, we tell people that about 30 centimeters from the point of impact is where you'll find most of the lead. And so it depends on how these people shoot the animal. Like if the animal is just a broadside shot, then it's generally in the front. But if it's a quartering shot, so the animal's walking towards the hunter and they shoot, then it can be throughout basically the entire animal.
Other international studies have confirmed that X-rays of shot animals can contain hundreds of visible metal fragments from a single bullet, much of it lead. There are also many thousands of microscopic fragments that are too small to show up on X-ray, although some of the other studies have detected these using synchrotron technology. It's these tiny, invisible fragments that worry Eric the most.
As a biomedical scientist, the worst type of lead exposure is like if you eat a lead sinker, you're probably not going to feel great because you just ate a lead sinker, but it's the surface area to volume, right? Your body can't absorb that whole lead sinker. It's going to exit. But if you have all these very small little bits of lead, that surface area, your body can actually do a much better job of absorbing that than it can that giant chunk. So even though the giant pieces of lead are more emotively worse, you look at them and you think, oh, I don't want to eat that. Those aren't the ones you really have to worry about. The ones you have to worry about are those really small, almost microscopic fragments that will be much more readily absorbed by your body.
For another hunter's perspective on this research, I catch up with one of Eric's NMIT colleagues.
My name's Simon Hunter. I'm a hunter, and mostly for deer and sometimes goats.
And do you eat the meat that you hunt?
Yes, we do. I usually give it to family or friends, yeah.
Now, because you work at NMIT, you've been aware of this research project that's going on here?
Yes, and I've worked with Eric Burns, and hunted with him as well.
Before the study, had you ever thought about the implications of shooting an animal with lead and then consuming that meat? Had that crossed your mind?
No, I hadn't. No, it was only through the research that we've been doing that I came to realise that. And after seeing X-ray imaging of meat that has been used for this research project. It was pretty clear quite quickly the extent of the spread of lead in the carcass. Yeah.
Has the study changed your behaviour as a hunter? For instance, has it changed what bullets you use?
Yes, it has. Yeah, I used to use lead based ammunition, and now I use copper-based ammunition. Now, it does the same thing very effectively, and it's slightly more expensive, but I'm willing to pay the slight increase in cost for the assurance that I'm not having lead in the meat that we consume.
Well, what I tell all the hunters that I talk with, and even the public presentations, is that it's your choice what you're using for ammunition. We just want you to know that this is a risk. People have said that, oh, well, then I just won't take the front of the animal, and that's a fine way to reduce the levels, but there is non-lead ammunition available if people choose to use that.
Although Eric's research focuses primarily on human health issues, his hunting passion has led him to the area of animal health, particularly the impact of lead on wild animals.
It was about 4 or 5 years ago. I was hunting and I had shot a chamois in the high country. And after we shot the animal, there was the Kia went at the carcass after I'd cleaned up all the meat, put it in the bag, and walking out, and I was thinking, wow, that could potentially not be good, right?
Eric's encounter with the scavenging Kia led to another research project, this time in collaboration with the Kia Conservation Trust, Department of Conservation, South Island Wildlife Hospital, Ngāi Tahu, and international experts such as Myra Finkelstein. Myra is an adjunct professor in the Microbiology and Environmental Toxicology Department at the University of California, Santa Cruz, in the United States. She is a world-leading researcher in the detection and impacts of lead.
All vertebrate species are very vulnerable to lead poisoning. So for scavenging species in general, yes, they can be affected because the way they feed on dead things that they find. And if those things had been shot with lead-based ammunition, they can inadvertently ingest bits of the lead ammunition fragments at the same time. And even a very, very small fragment, just as big as a couple of grains of sand, has enough lead in it to kill a condor, or a Kia for that matter.
I'll come back to Kia in a moment, but Myra mentioned the California condor there, and that really is the poster bird for the negative health impact of lead-based ammunition on a critically endangered species. And we know about that because of Myra's pioneering work.
So our work has shown that lead poisoning from ingestion of lead-based ammunition fragments when they're scavenging on carcasses is the principal source of lead poisoning to California condors. And our recent published work illustrates that California condors in California, lead poisoning is still preventing the species from recovering.
Back here in New Zealand, researchers working with Kia have known for quite a while about lead poisoning in these inquisitive mountain parrots. Science advisor Kerry Weston leads DOC's Kia recovery work.
Yeah, as you know, lead is really bad news for Kia. But I guess the problem is that they seem to kind of like it. You often see them chewing on lead flashings and lead head nails on buildings. And we think it's because they like the sort of sweet taste of it, and it's also really malleable and they just enjoy chewing on it. But unfortunately, it makes them really sick. And with high enough doses, or if they eat enough of it, it can kill them.
This matters because Kia are listed as nationally endangered, which is the second highest threat category. It's estimated there may be as few as 1,000 breeding birds in the South Island. Lead poisoning is a particular issue for the Kia that hang around the small alpine village of Arthur's Pass.
Any Kia that gets sick in Arthur's Pass is immediately brought down to Pauline Howard at the South Island Animal Wildlife Hospital. We were down at the hospital with Pauline last year sometime, and she had a Kia that had just been brought down because it was in the car park near the train station down in Arthur's Pass, and someone just went and picked it up. If you see a Kia out in the wild and it's healthy, it looks fine. The feathers are beautiful, but these ones, their feathers start to stick up like a little mohawk, and they just kind of wander around a little bit, kind of drunk, and yeah, they look sick. They're not inquisitive at all. They just kind of lay there.
Vet Pauline Howard treats Kia suffering lead toxicity with chelation therapy, which basically mops up lead in the body. Some birds are saved this way, but not all. Kerry Weston says that DOC and the Kea Conservation Trust have a long-running program to test kea for lead. The results from more than 800 blood samples collected over 16 years show that more than 40% of the birds tested had been exposed to lead. Nearly a quarter of them had concerning blood lead levels. And another database, which records causes of death for native birds, reports that nearly 20% of the kea that were autopsied were suffering from lead toxicity.
We've been lead sampling kea for quite a while now throughout their range. We've been doing this for about 20 years, actually. This lead sampling's actually been really useful because it's helped us identify where the hot spots are and where kea with elevated lead levels tend to be. And often this has been around the alpine villages and settlements where there's a concentrated lead source in the buildings. We've been focusing our lead removal efforts in these areas to try and remove as much lead from the buildings as possible. So we've removed something like 6 tonnes of lead out of buildings across the South Island in partnership with the Kea Conservation Trust. But then in 2018, we did some sampling up a remote valley in South Westland, and we found that lead levels up there were actually really high as well. And that was quite far away from any sort of concentrated source of lead or any lead on buildings. And that, to us, highlighted a risk from another lead source, lead ammunition.
This area in South Westland was a focus for DOC's Himalayan tar control program, which meant lots of tar were being shot there. And this was an opportunity that the kea were quick to take advantage of.
Carcasses are a really important food source for kea, so they've keyed into the high energy content of ungulate carcasses, and they tend to congregate on the carcasses in quite big flocks, and that's where they seem to consume the lead ammunition.
Tom Brookman leads DOC's tar control program, and he says DOC responded quickly to the discovery of high lead levels in these backcountry kea.
The tar program within Kea Habitat has made a transition since about 2018 to moving lead-free ammunition. We've been completely lead-free since about 2022, so it was sort of probably about a 3-year transition that was done in response to some really very preliminary findings on kea blood lead levels. It didn't attribute the source of the lead, those analyses at the time, but the risk was seen as great enough to take a precautionary approach and transition. So the tar program is probably the biggest single wild animal control program that the department runs, and certainly the biggest within Kea Habitat. Yeah, so it was seen as justified to take a precautionary approach for that program.
Eric, Kerry and their Kea collaborators decided to investigate exactly what lead kea were being exposed to. And this is when Myra Finkelstein became involved in the research.
So my lab basically measures lead and different lead isotopes. So it's sort of like a signature of lead. It's kind of like a fingerprint, but not quite as unique. So we specialize in doing that to understand the concentrations of lead in different biological samples, as well as the isotopic signature to evaluate what the source of exposure could be.
Myra was sent 91 kea blood samples, along with examples of the lead-based ammunition used by recreational hunters and by DOC in its tar control operations, along with some lead roofing nails and flashing taken off backcountry huts.
The first study I did was look at samples of the huts and samples of ammunition, and we illustrated, yes, they had very, very different signatures.
Did you expect such a clear signature?
The huts, that lead is from a very long time ago, and the ammunition is much more recent. And so because of that large time span of when the lead item was made, we thought that it was possible that they would have different signatures. But, we didn't know until we looked at it.
Myra and Eric were delighted that the two potential lead sources showed such distinct isotopic signatures.
Most importantly, she was really excited the first time I spoke with her, and she said, "This data is great. It's so clean. It's like, I've never seen this before where like the lead flashing is and all the stuff looks like it came from one shipment. It's all grouped together and then this is grouped together. So it worked out really well. Like scientifically, the experiment went well.
The next step was for Myra to analyse the lead in the Kia blood samples and see if its isotopic signatures matched the ammo or the roofing material.
I actually find it's quite remarkable because for all of the Kia that we looked at, we wanted to see for the ones that we decided were exposed because we all have a little bit of lead in us. So if somebody looked at, like if I looked at the lead in my blood or the lead in your blood, hopefully we're not eating roofing material or ammunition, we'll still have detectable levels of lead. So we decided for the Kia to look at the ones that were exposed above a level that we thought was kind of above this background level that you see. And for those, we found that about 70% of the birds, their lead signature in their blood was consistent with either ammunition or huts. So about a third were ammunition, a third were huts, and the final third looked like a mixture of the two.
These striking results have just been published in the journal Conservation Letters. 35% of the Kia had got their lead solely from lead-based ammunition, 32% solely from roofing materials, with 33% seeming to interact with both sources.
We also, because we knew where the samples were collected from, were able to lay a map out, and we're able to see that the ones in Arthur's Pass, that looks like a lot of flashing. The ones from the back country, like up in the Pierce Valley, where we know that there's a lot of culling going on of tar, those look like they're more lead ammunition.
These results give everyone plenty to think about.
The Care Recovery Group, which comprises members of DOC and Te Runanga o Ngāi Tahu and the Care Conservation Trust, have advised a progressive transition away from lead ammunition for all of DOC's wild animal control programs in care habitat.
DOC's Tom Brookman says work is well underway to phase out the use of lead ammunition.
We've now got an ongoing project that looks at different types of lead-free ammunition and their suitability for our control programs, and also at whether there might be ways that we can use lead-based ammunition that would mean the lead is therefore not available to Kia. So there's a bunch of that work already happening within DOC, and it'll go into the mix along with the findings of this research to inform our next steps. But I think we've put ourselves in a pretty strong position overall to make some well-informed next steps for Kia conservation and benefits to Kia in regards to lead in ammunition, while also maintaining our ability to deliver effective wild animal management.
This recent research published in Conservation Letters included population modelling for Kia, which showed that even a small reduction in deaths caused by lead poisoning could make the difference between Kia going extinct or growing in numbers.
Predation still remains the number one threat to Kia. They get absolutely hammered by stoats and feral cats, and DOC puts a huge effort into controlling those predators. But every threat that affects their survival, we need to address when it's a declining species like this. So removing lead from their habitat is also a real key priority for us.
This is not just an issue for DOC. There is plenty here for recreational game hunters to think about and respond to too. In the published paper, Eric and his colleagues write, and I quote, "We suggest that an immediate transition to the use of non-lead ammunition for all forms of shooting within Kia habitat will significantly contribute to the recovery of this iconic species in taonga." There is precedent for this. To help save the condor, California has banned lead-based ammunition. In many countries, the use of smaller lead shot to kill waterfowl such as ducks on or near waterways has already been banned. This is because the waterfowl were eating lead shot along with the grit they used to help digest their food. This was bad for the birds and bad for the humans eating them. In New Zealand now, only non-toxic, i.e. non-lead shot, can be used when hunting waterfowl within 200 metres of water, regardless of the type of gun.
Well, I'm hopeful, the work that we do, we're hopeful that being able to help identify plausible sources of lead to these endangered and threatened wildlife, then we can move forward to try to reduce the exposure to these birds. And so for lead-based ammunition, there's actually really great non-lead alternatives that you can use. So it's not that people can't hunt anymore or can't do control programs anymore, but there are non-lead options that are available that would not then result in potential lead poisoning of your wildlife or your endangered kea. We've known lead is toxic for vertebrate species for over 100 years. And we also know that if you eat meat that's shot with lead-based ammunition, you get a little bit of lead in your blood. You get exposed to lead. And there's no level of acceptable lead exposure for young children. So lead is really toxic. And I think anything that we can do to help prevent wildlife and ourselves from being, exposed to this highly toxic element is a good thing.
Thanks, Myra. Myra Finkelstein is an adjunct professor in the Microbiology and Environment Toxicology Department at the University of California, Santa Cruz in the United States. Thanks also to Dr. Eric Buens and Simon Hunter at the Nelson-Marlborough Institute of Technology, and to Dr. Kerry Weston and Tom Brookman at the Department of Conservation. This story was produced by Alison Ballance and engineered by Mark Chesterman. There are links to the 2 research papers discussed in the story, along with further background information on the written article for this episode. Find it at rnz.co.nz/OCW. You can also subscribe to our monthly newsletter there. And if you want to get in touch with us with comments, questions, or story ideas, you can email us at ourchangingworld@rnz.co.nz. Tēnā koe I whakarongo mai. Thanks so much for listening. I'm Claire Kincannon. Have a great week. Kia pai, the wiki.